Hello guys, hello everyone. Thank you for joining us. So, I hope you're doing well. I think it's okay. We have a new talk. I think this talk will be useful not only for who use API and but for all EPAM testers. And let me introduce Azad. Azad, go ahead.
Yeah, thank you, Tatiana. Hello, everyone. Thank you for joining today's Tech Talk. So let me share my screen and we will start our presentation. Okay, so let me tell you what we are going to talk about today. So first of all, we will define what is GraphQL. We will compare it with REST API as the most common API. We will investigate GraphQL query structure. We will learn query types in GraphQL. We will learn GraphQL schema, or what it consists of. And of course, we will talk about how to test GraphQL API. Also, I will share some useful tools and links so you can use it in your learning path. But first, let me briefly introduce myself. My name is Azad Kaprizov. I am a senior software testing engineer in EPAM. I work more than 4 years in testing, and mainly my work is functional testing, API testing, and some other kinds of testing, including GraphQL, of course. Okay, so let's get started. Brief history of GraphQL. So Facebook started GraphQL development in 2012 and released a draft specification and reference implementation as open source in 2015. And in 2018, GraphQL was moved to the newly established GraphQL Foundation, hosted by nonprofit Linux Foundation. Then, in 2018, the GraphQL schema definition language became part of the specification. And now, today, many popular public APIs adopted this technology as default way to access them, like Facebook, GitHub, Yelp, Shopify, and many, many others. So what is GraphQL? Let's take a look at definition. So GraphQL is a data query and manipulation language that allows specifying what data is to be retrieved or modified. A GraphQL server can process a client query using data from separate sources and present the results in a unified graph. And the language is not tied to any specific database or storage engine. There are several open source runtime engines for GraphQL. So basically, it means that GraphQL is applicable to almost any project, any technology, any programming language. So let me illustrate how it works, how it looks. So let's say we have a database that contains data, for example, data for users, data for posts, for comments, let's say some social network. And we can use GraphQL to retrieve some data from users. Let's say this is our query. We want to get some list of users with name and their ages. But what if we want to also get associated posts of these users? In GraphQL, it's really simple. So in this case, our query will be a little bit modified. So in user, we specify that we want to get a name for each user, and also we want to get a post of this associated user. So if we want to demonstrate it graphically, let me take a pen. What GraphQL is doing, he is taking data from users and also takes data from posts for each of these users. So let's say for this user, we have 2 posts. For this user, we have 1 post, and for this one post. So we don't need to make two queries, two requests to our server, we can do it in one simple query, one request. So if we compare it to REST API, so on the left side, this is how it looks in REST API, right? So we should call user endpoint, we should call post endpoint, comment endpoint, etc. to get this data. But in GraphQL, we use only one query that retrieve data from all these data sources. So if we, again, compare GraphQL to REST API, so for example, if we take endpoints, so for GraphQL, we have only one, just single endpoint, but for REST, we will have multiple endpoints. As for over or under fetching data, in GraphQL, there is no such problem. We fetch only those data that we need. As I demonstrated before, in the query, we specify what data we need, like name, age, etc. But in REST API, we will have some, not issues, but like moments with over or under fetching data because our response is fixed on server. As for caching, it's on in GraphQL, it's on client side, and in REST API, it's on server and CDN. As for versioning, in GraphQL, it's built-in via deprecation, and in REST API, it's through URLs. As for documentation, in GraphQL, it's self-documented schema. We will talk about it today, later. I will show you what schema is, and it's really nice documentation. And as for REST API, it's well, usually it's a separate documentation. And for data fetching, it's in GraphQL is declarative, yeah, where we specify what data we want to fetch. And in REST API, it's predefined. Okay, so let's talk about GraphQL query structure. That's components that GraphQL query might contain. They are fields, arguments, variables, aliases, fragments, and directives. So let's briefly talk about each of them. Fields. Fields represent specific attributes or properties of an object, such as its ID, name, any other relevant data. And they are the building blocks of GraphQL queries and used to specify the exact data that client wants to retrieve from the server. So in this example, let me take a laser pointer. So in this example, we have a query that is called get users. And here we have two objects. The first one is user, and the second one is post. The post is inside users. And here for each object, we specified fields. For user, it's name, and for post, it's content and date. Even if server contains, or database contains many others fields, many other fields for these objects, we will get only those fields that we are specified here in the query. Okay, the next component of our query is arguments. Argument is a way to pass data to fields and nested objects within a query. And arguments allow you to refine and filter the data you request from the server, making your queries more specific. So in this case, we use, for example, in this query, we use argument ID and specify a value as 1. So we will get only one user with this ID. We will get name and email for this user, but also we can specify, let's say it's a kind of built-in arguments like limit, for example. So in this case, if I specify limit for 100, so for this user, I will get only 100 followers and not more. And yeah, as you can see, the arguments are specified in such parentheses and passed to the query. Okay, the next component is variables. Variable is a way to parameterized queries and mutations. We will talk about mutation later, allowing you to inject dynamic values at runtime instead of hard coding them into the query. So on previous example, we used how to say not static values here in arguments, but if we want to use dynamic, we can use variables. So in this case, for example, we specify variable user ID, its type, and we pass it here in this in the query. And here is our variable user ID is passed separately. Well, not together with the query, but as a separate separate item. Let's say in a request body. So we will pass this variable, which will be used here in this query. Okay. So the next thing is aliases. Alias allows you to rename the result of a field to something more descriptive or to avoid conflicts. So let's say we have a query. We want to retrieve data for products, for users, but both objects have fields that share the same name, like name field and description field. So to avoid these naming conflicts, we can use aliases. In this case, for users, we specified username, colon, and original field name. User description, colon, and original field name. So when we run this query to our system, we'll get something like that. Okay. Sorry, I had some lagging. Can you hear me? Can you see my screen?
Sure. It's okay. Go
Okay,
ahead.
okay. So when we are running this query, we will get something like this. So in the response, we will get for products, the fields will be name and description, and for users, the fields will be username, user description for each object, for each user. So we will not have any conflicts in field names. Okay, let's move on to fragments. So, fragment is a reusable selection set of fields that can be included in multiple queries or within different parts of the same query. So fragments help reduce redundancy and improve the maintainability of your queries by allowing you to define common fields once and reuse them wherever needed. So in this case, let's let's describe what we have here. So we sent two requests to get information about two different users. So let's say with ID1 and ID2. And for each request, we create aliases, left comparison and right comparison. And we use a comparison fields here, comparison fields fragment that contains a set of fields that we want to get for each user. So fragments allow us to avoid code duplication and use the same set of fields in multiple scope requests. So if we run this query, this one, in response, we will get something like this one. So we have two objects, left comparison and right comparison, and each of them contains data for two different users. But we specified these fields only once. So yeah, we can reuse it, and yeah, it helps us to avoid code duplication. Okay, so the next thing is directives. Directive is a special instruction that can be attached to a field, fragment, or operation to modify its behavior during execution. So in this example, we used include directive. and the email field will only be included in the response if the include email variable is true. So here we specified our variable include email, and here is our directive include if include email. So let's okay. So let's move on to the next one. It's another one. So in this case, it was include, but we can also use vice versa version of directives like skip. For example, if we use skip directive for some field, so the followers will only be included in the response if get followers variable is false. So it works vice versa, right? So include or skip. It takes boolean values like true or false, and if it's true, then we will skip this field in the response. So that is our variables that we specify. Okay. So let's talk about GraphQL query types, or also known as root operation types. There are three of them: query, mutation, and subscription. And a little note for further discussions, it's if we're talking about HTTP as the most common protocol option, all types of requests in GraphQL are sent via POST, but GraphQL can also work via WebSockets, gRPC, and other transport protocols. But since HTTP is, I believe, the most common protocol, we will we will take examples comparing to comparing to the rest, which works on HTTP protocol. So the first query type is query. Queries are used to fetch data from the server, and they are analogous to GET requests in REST APIs, and the query allows you to specify exactly what data you need, and the server responds with the requested data. So here's the example that you already seen before. That's just a simple query to get some data from server. The second type of query is mutation. So mutations are used to modify data on the server, like create, update, or delete. And they are similar to post, put, patch, or delete request in REST API. And the mutation defines the shape of the data that will be returned to the client after the operation is complete. So for example, in this case, we have a mutation query that is called create user with some variables, with some arguments. We pass them by using these variables. Okay, let's move on. So when we run this query to our server, we in the response we will get something like this: create user, name, age. So that's what we specified in our request. Okay, and the third type of our GraphQL queries is subscription. And subscriptions are used to listen for real-time updates from the server, and they allow clients to subscribe to specific events and receive data updates when those events occur. And subscriptions are often used for real-time features like notifications or live data feeds. So the query is pretty simple. We just specify subscriptions, the name of the query, and what data we want to get. So in the response, we will get something like this. Each time when user is created, we will get this response that user is created with name and with his age. Okay, that's three main query types in GraphQL. So now let's talk about GraphQL schema. What is GraphQL schema? It is a blueprint that defines the structure of the data available through the GraphQL API. It specifies the types of data, the relationships between those types, and the operations, queries, mutations, subscriptions that can be performed on the data. And essentially, the schema acts as a contract between the client and the server, ensuring that queries are validated and executed correctly. And schema consists of two components, types and resolvers, that we are going to investigate right now. So this is the example of schema on the right side of your screen. So here we define types: user, type post, type query, mutation, and subscription. And for each field, we define data types like int, string, etc. Non-null fields are marked by exclamation mark. For example, here for user, for post, for arguments here, and lists are wrapped in square brackets, like here for post, for user. That means that in the response we will get a list of posts, a list of users, etc. So regarding these lists and non-nullable fields, so let's talk about it a little bit. So for example, we have a few options to use this exclamation mark and a list, and all of them are a little bit different. So for example, if we use just a list, for example, a list of books, and we don't use this exclamation mark, it means that the response might be null, and the items inside this list also might be null. So here are the all allowed return values, like empty list, null, list that contains null, and of course some object in the list. But if we specify this, if we set this exclamation mark inside our square brackets near book, then it means that it's not allowed to contain a null item inside the list. So it's allowed only, so allowed return values are empty list, null, and of course some object in the list. But we cannot, but the response cannot contain null inside the list. Another case, when we set this exclamation mark outside of the list, that means that the list itself cannot be null. I mean, the response itself cannot be null. So we can get as valid values, we can get empty list, list which contains a null, and list that contains some object, but we cannot get a null. And the last case, when we set this exclamation mark inside square brackets and outside square brackets, it means that the response cannot be null, and the response cannot contain lists that cannot contain null inside the list. So valid options are empty list and of course, some objects in the list. Okay, I hope it's not too complicated. Let's move on. Let's talk about some data types in schema. So there are a few of them. They are scalar, object, that also include that root operation types like query, mutation, and subscription. We also have input, enum, union, and interface. So let's talk a little bit about all of them. So first, data type is scalar. It's let's say like primitive data values like integers, float, strings, Boolean values, and IDs, and they are the default values that already built in GraphQL. But developers are also allowed to create their own scalar types, like for example date, URL, etc. So developers can extend this list of Scala types in their projects. So for example, here uh, we used integer, string, integer, etc. But if we, for example, if we need to specify, let's say, birthday of the user, so it would be better to use data type instead of just, for example, just a string or some other. So yeah, we can do it. The next type is objects. Object type contains a collection of fields, and each of which has its own type. And two object types can include each other as fields. So, for example, here, okay, let's, yeah, for example, for type post, inside of the type post, we can include user type here that we defined above, and we can use this user as a field here. But user contains some other fields in it, right? Like ID, name, age, likes, etc. Okay, so objects are pretty simple. And also, yeah, these operation types like query, mutation, subscriptions are also uh, they are also objects, right? But they are objects with reserved names, query, mutation, subscription, and they can contain these fields. And basically, when we create, for example, let's say we create get users here in the type query, and if we compare it to REST API, in REST API it would be something like that, right? Like, let me use my pen. So API slash get users. It would be in your URL, get users, right? So it's your endpoint that you would use in REST API. So here we define it in type query in GraphQL, and we create this list of let's say endpoints. Okay. I hope it wasn't too complicated. Another type is input. Input types are special objects types that allow you to provide hierarchical data as arguments to fields. Since we cannot specify variables inside of curly brackets like objects in our arguments, we need to use this input type. Oh, 1 second. Yeah. So for example, in this case, we created type input, which is called blog post content, and it contains two fields, title and body. And if we want to create type mutation, for example, create blog post, right? So here we specify field content, and its data type will be blog post content. Since we cannot specify this this whole like, let's say, object in curly braces, we specify it here in one line as one input. For example, the same works for update blog post. We specify ID, which post we want to update, and the content that we want to provide. Okay, the next one is enum. Enum is similar to a Scala type, but its legal values are defined in the schema. So for example, here we created enum, which is called allowed color. It has three values like red, green, and blue. And we also specify type query, which is called avatar, and we specify border color. And the data type of this border color will be allowed color, this enum. So it would in the query that we will be using, it would look like this. So query get avatar, we specify this query name and provide argument border color with red value. This is one of these three values that are valid for this query for this case, like a drop down on UI. The next type is union. So union, a field can have a union or a list of that union as its return type. So in this case, it can return any object type that's included in the union. All of the union's included types must be object types, not scalars, inputs, etc. So, for example, in this case, we specify union search result, which contains two types, book and author. So we cannot specify here any scalar types or input types. It's always should be object. So the following schema defines a search result union that can return either a book or an author. And the search result union enables this query search to return a list that includes both books and authors. So let's take a look what it would look like in the query. So if the field's return type is a union, GraphQL clients don't know which object type a field will return. To account for this, a query can include the subfields of multiple possible types. So every object type in your schema automatically has a field name, type name. Developers don't need to define it; it's automatically is existing. So this type name field return the object type's name, for example, like book, author, etc. So here is an example of query for the schema. So here we define in this query get search results. We define some argument which can, for example, books and authors that contains Shakespeare, and we want to get type name for each result. And also we specify with these three dots on data type book what field we want to see, and the same for author, three dots on author and what fields we want to see. So if we run this query, we will see such response. So here we see two results. The first one is for data type book, and it has title The Complete Works of William Shakespeare, doesn't matter. And the second type is author object, which contains its name as we requested. So that kind of like let's say polymorphism in our schema in our query. Another one type is interface. Interface specifies a set of fields that multiple objects can include. Object types can include. If an object type implements interface, it must include all of that interface's fields. And a field can have an interface or a list of that interface as its return type. So in this case, it can return any object type that implements that interface. So yeah, it sounds a little bit complicated, but let's try to see on the example. So here we have interface, which is called book, and it has two fields, title and author. Title has string data type and author has author data type. Then we have another two types that implement this interface. So first of those is a textbook, type textbooks. It implements type book, interface book. It must contain title as interface. It must contain author, and also it can contain any other fields besides these two. So for example, for textbook, it would be courses, which has course data type. And the second one is a coloring book that also implements this book interface. It has title, it has author, and also it has colors here. And we also create a type query to retrieve some this data, uh, a list of books. Okay, so if we go to our query, we can use something like this. Query get books, and for each of them we can get title and author, since all the types in our schema has these two fields like title and author. So we can just query those data. But what if we if a field's return type is an interface, clients can query that field for any subfields, but also clients can query for subfields that aren't included in the interface. So this query uses inline fragments to fetch a book's courses. So let's, yeah, this one. So in this query uses inline fragments to fetch a book's courses if it's a textbooks, or its colors if it's a coloring book. So in this case, we again use this type name property in our query. We want to get title, but also if it is textbook type, we will get courses, its names of these courses, and for coloring book, we will get colors. So if you run this query, let's see what we will see in the response. So we have two objects in the response, right? So first of them, type name is textbook. It has title and it has courses. But also we have another type, which is called coloring book. It has title and it has colors. So yeah, it's another another implementation of polymorphism in our schema, in our queries. Okay, that was schema. That was the first part of our schema, types and data types. But also we have resolvers. So resolver is a function that resolves a value for a specific field in a schema. So resolvers act as a bridge between GraphQL query and the underlying data source, such as a database or another API. And they are responsible for fetching the data and transforming it into the format expected by the client. So in other words, it's logic. Yes, it's implemented logic on our server. These resolvers. It's a function that you don't need to remember all this code. It's just as an example. So, for example, if we have a query which is called users or user, we get some arguments. Then we use these arguments to fetch some data by ID, etc. So this is the logic for each of our query for our data types. The same is for mutations. For example, here we have a query called increment like. So it has some logic. It finds required data in database. It makes some manipulations with data. So basically, it's just our logic, let's say. Okay, so let's move on to testing. So as any type of testing, in GraphQL, we will start with testing our documentation. And the documentation in GraphQL is a schema. So what we can test here in our schema, we might verify that we use clear names for our types, like for our fields, etc., for our let's say methods like get, for example, get user or get users, increment likes, etc. We might verify that we use specific types for special data. For example, if it's a birthday, we should use date, for example. If it's URL, if it's ID, it should be ID. Well, in the perfect case, right? So we verify that we allow for missing data. I mean, these nullable or non-nullable values if they are used correctly. Keep it simple. Basically, GraphQL allows you to create very complex structures. I mean, we can have very complex references between different objects. Like, for example, in this case, it's a simple example, right? So in user type, we have just one post, one reference to post type. But GraphQL allows you to create hierarchy. So inside of post, we also can reference to other types. In other type, we can reference to other types. So it's not necessary. Well, usually it's not necessary. So if the schema is looking very complex, so maybe we can simplify it ideally. What else we can test? Of course, our root operations, right? So we can check for correct data retrieval, that we get the data, correct data that we requested. We can validate the response structure. We can ensure that all fields are present in the response. We can validate the data types. We can also test for optional and required fields like non-null and null, especially for lists. Um, and of course, we can make some negative tests, for example, to request some non-existing fields, etc. So, of course, it's not a complete list of checks in GraphQL. Most of the most of the test techniques, test cases that we use in REST API, they are applicable to GraphQL. So don't hesitate to use them here as well. But it's just a list of some specific verifications that might be applicable to GraphQL exactly. And of course, well, we mainly talked about some manual testing, but of course, any other types are applicable to GraphQL. As for REST API, like automated testing, performance testing, security, etc. So they are also applicable here. Okay, and just a few words about testing tools. Of course, you are familiar with Postman. It can be used to test GraphQL API, but I will also tell you a little bit about Apollo and some other tools. So first of all, when I start testing GraphQL on my project, I face such a issue. When I open my network tab in my web browser in Chrome, I see that just a list of GraphQL responses. It's not possible to differentiate the requests. Well, by default, I need to click on each of them, and only in the response I can see query name, the response itself, but here on the network tab it's not possible. So one of the solutions to see GraphQL queries in your web browser is extensions. So for example, here I use extension called Querio. There are many others similar. So here in the list, I can see the list of my GraphQL queries. I see the query itself. I see variables that I used and the response, of course. Here's my endpoint and headers for request and for response. There are, as I said, there are many of them in Chrome Web Store. So basically, they are doing almost the same. So it's up to you which of them uh, which of them you like. You can use any of them. Okay, so another tool for testing is, of course, Postman. If you go to body tab here, you will see this radio button called GraphQL. So when you click on this GraphQL button, you will see this interface to enter your query, to enter your variables here, and here you will see your response. Of course, don't, well, usually it's a HTTP protocol, so don't forget to change this request type to post. And yeah, after send, you will see your your response. Okay, so another one, the most useful, the most convenient tool for me, at least, is Apollo. So let me demonstrate in browser. 1 second. I will share it. Up 1 second. Okay, I hope you see my screen. So basically, Apollo is not just testing tool for GraphQL. It's a big complex tool to set up your GraphQL API to test it, so etc. etc. So basically, it's a development tool. But I want to just to demonstrate you how project would look like in Apollo.
Azad, we see only your screen. Your screen and your
don't you see my web browser?
No, not web browser.
Oh, okay, 1 second. Okay, what about now?
No, nothing changed.
Interesting. Let me try one more time.
Maybe use present.
Yeah. So do you see now?
Yes.
Okay,
Thanks.
great. So basically, this is a project in Apollo that's a overview page, some README files, etc. Then here we have a schema page where we can see all the available queries, their fields, their data types, some details, etc. It's already categorized by query types, mutations, subscription, etc. We can see all the objects that we have in the schema, all the scalars, enums, etc. All of them are available here. It's a reference presentation of the schema, but also we can see SDL schema definition in schema definition language. Here is all of them are also specified as a documentation here. And the third type is visualization. So here we can see all these references between different types, how they work. So one this capsule object type is refers to Dragon. Dragon is existing here. It contains these fields. It also contains some distance type. So all of this we can see here on visualization. But the main page that I want to share with you today is Explorer. So if we go here, we will see something like this. And if we go to the root, let's clear it. Here we'll see this our query types, query imitation subscription. Let's say we want to make a query request. We go to query. So let's say we want to use capsules here. And here, when we go to capsules query, we can see all available arguments that we can use and all available fields that we also can use. So let's create our query here. So let's say we want to see, so let's add all of them by clicking this button. So you can see that we have some issues here, right? For Dragon, that's because for Dragon object, it's an object, so we don't specify any fields that we want to see here for Dragon object. So to add them, we can go into the Dragon object and add any fields that we want to see, like I don't know, ID, description, etc. So when we go back, we also see this issue for missions. So we go into the missions here. No, not landings. Where is missions? Here is missions. And let's say we want to add a name. Okay, that's a variables. Let's remove them. Run our query, and here we see our response. All of the objects. If we don't need missions, we just remove them. If we don't need Dragon, for example, object, we remove it, run our query, and we see only those fields that we need. We can use arguments like, for example, limit. We click on it, and we, for example, don't need to see all of them. We want to see only 5. Let's say 5.
Thank you,
Run
Azat.
our query. Mm-hmm.
Thank you. We have 8 minutes to end. And
Yeah,
we have
so okay. So
really,
I'll, I'll,
really interesting, but
I
the
will
time.
share this link to the
Mhm.
sandbox, so yeah, everybody will have a chance to see it.
Okay, so we have a compliment from Ali. Ali said, "What it's going great, very great. I means it's about what you talk. It's perfect." And we have uh, Kanat ask it. Can we stop switch off subscription?
Mm, to be honest, I don't know. I haven't used it in my project, but I believe that there should be a possibility to do it. Yes, to unfollow. Yes.
Okay, we have question about Azat. Can you tell about the advantages of GraphQL against SQL, against PostgreSQL, for instance?
Well, SQL is a absolutely different language, right? It is used for databases, but yeah, there is some. So let's say GraphQL is kind of SQL for API. Let's say maybe I'm wrong. Yeah, maybe I'm wrong, but yeah, there are some similarities between those two languages, technologies, but they have different implementations. They have different goals. So we don't need to compare GraphQL and SQL because GraphQL is used in APIs and SQL in databases. So yeah, let's not compare them, I would say.
Thank you, guys. Do you have any questions to Azat? I won't remember it, but if you need the presentation, you can text me or our speakers. No query, no query. Okay, we're waiting a minute. Azad, very thanks. Very great talks. I will definitely try to use it in my work.
Yeah,
Yes.
thank you.
Yes.
I hope
Yes.
it would be
Yes.
useful for all of you.
Okay. And guys, I remind you for relevant questions for our speakers. Yes. And the participant will receive coins for the relevant questions. Whoever has the most coins of the in the end of the year, yes, will receive the gift from our community. And we see queries. No queries. No queries. Azad, thank you. Thank you very much. It's
Thank
very
you.
useful. Very useful. Thank you.
Thank
Very
you.
interesting.
Thank you for the
Guys,
invitation.
have a nice weekend and I hope see you next talk. Bye.
Bye, everyone.